Okay, everybody, it's Mr. Bell's back again, and we're going to try a little video today on something called the law of sines. And I know that you've seen this before, but I don't know how detailed it has always been. So I'm going to try and give you some information, some facts on it. This is going to help you with section, I believe it's 5-5 out of the pre-calc book. So here we go. First thing, law of sines. Law of sines basically deals with any triangle in terms of a relationship between its sides and its angles. And typically we say we use these things for non-right triangles, but honestly they work for right triangles. I think SOHCAHTOA is just a little bit easier for right triangles. So again, this will work for any triangle, right triangles or non-right triangles. But SOHCAHTOA, sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent only works for right triangles. So first off, what exactly do we need to know? Well, there's this formula that shows you right here. Sine of an angle over the side opposite that angle is equal to sine of another angle on the same triangle over the side opposite it is equal to another sine over the third angle and its side opposite. So this picture would look just like this. In terms of what's going on here. So if this is angle A, then the side all the way across from it would be considered side A, and those do have to match up when we do these things. Okay, so when do we use a law of sines? Well, there are three possibilities for law of sines, and we use it just like what we did when we proved triangles congruent, and we used them based on their markings. So this one, if you go around in order, it'll have a side, and an angle mark. Now I can't call it this way. I can't go this way around. Watch. Cannot do this. Can't go this way around. You can call this side, angle, side, even though those are the three markings, because if I call it side, angle, side, side, this angle would have to be one that I'm using that's marked and is known, and now it's skipping that. So I can't skip it. So when we do this, we say this one's side, angle, it means that it has a side. And then the very next time that it's marked is also a side, and then the very next time that it's marked is an angle. So that's a side angle relationship. And you have to be able to differentiate between that. So this next one, you can see that I've got an angle marked, and then a side marked, and then the third one, an angle marked, a side marked, and an angle marked. And that's pretty much what they're telling us. And the problems is they're going to give us 3 bits of information. You plot them down in the triangle and you determine them. If they happen to, and this is a big if, I'll go ahead and put this right here in the little box. If they happen to give you a side, angle, side, or a side, markings, you're going to use something called the law of cosines, and that is not in this video. I'll have a separate video for that, okay? So just so you know, in case you run across that, those 2 things were law of cosines, different video, different formulas. So here's the deal with some of these triangles, and this is that AAS, awesome, will always work. ASA, awesome, will always work. The problem is this SSA situation. What happens when we have 2 sides and an angle following those 2 sides? Well, the concern is that we have different possibilities here. In fact, there are 3 choices. Like you can see right here, I have this little side that's given, which was 2, and it's connected to a side which is length 15. And then there's an angle given that's 30 degrees. So a side, and then an angle. But you can see if this thing's only length 2, and I probably have it longer than 2 compared to this being 15, think about that, 2 going across, you can see that. It just can't touch. It's too small. What happens with this is if you were trying to solve for the angle that's up here, and you did sine of missing angle over 15 equals sine of 30 over 2, you would see that it gives you something that's out of range, and it's not possible. Okay, so algebraically doesn't work. Visually you can see it's just not long enough to touch. Okay, so that's why we call this little s, big SA, where little s simply means that this side is too small with this bigger side, smaller, bigger, following that angle. However, little s, big SA could work. It just has to be closer to being able to touch. And in this case, you can see it over here on this one. I got two sides that are 8 and 8, and then this side here is a 10, and this side is a 30 degrees. And I just made up those numbers, so I'm sorry if they don't work. I think they do. We can go ahead and we can move this to a 9. That should pretty much guarantee that they will. And you can see that it touches 8 going this direction. It also touches 8 going that direction. So there's actually 2 possible triangles when you're given that information. A side length 8, a side length 9, followed by an angle of some amount. So this SSA situation here, one, I got a situation, boom, I can't get a triangle at all, it's just not possible. 2, I get 2 different triangles. And then this situation, where I have a big S, a little s, and an a. So a big S, side 14, a smaller side, side 5, and an angle 30. This one's always going to work for me, and I don't have to worry about it. So I can always go ahead and do law of sines with that one. It's just I have to be concerned about these 2 possibilities here. Okay, so let's give this a shot and see what happens with some of these ones. So the first one I'm going to do is I'm going to give you an angle B, and I'm going to make that 40 degrees. And I'm going to give you an angle A, and I'm going to make that equal to 32 degrees. And I'm going to give you a side C, little c, and let's make that 24. So if I've given 3 bits of information, the first thing that I'm going to want to do is I want to draw a picture of this situation. So I'm going to try and make this work out okay. So I got 2 angles, and it looks like the side that's between them. So here we go. So let's draw a line that's 24, and then an angle of 40 degrees coming off of here, and then an angle of 32 degrees coming off of here. And they don't have to be perfect, but you can see that they'll touch someplace, and it's pretty obvious. There's only one triangle that's going to work right here. Okay, and you're like, well, that's angle, side, angle. How does that work out? Well, I know that if this is 40 and this is 32, that's a total of 72 degrees, which means I have to know this angle up here, 108 degrees. And I can just reference that from the 3 angles of the triangle, and I can still use law of sines. So let's go ahead and find out what this length is right here. I would call it X, but technically if this is big angle A, then we're going to reference that as little a. And if this 40 was big angle B, then this is little b. Again, this was little c, and big angle C. So I'm simply going to write, if I'm trying to find out A, side A, I'm going to do sine of angle A, 32 over A, unknown A, equals sine of 108 over little c, 24. And now I've got this little a on the bottom. I'm like, I gotta get the a out because that's my variable. So I'm going to take this and I'm going to bring it upstairs over here. That basically means I'm multiplying by both sides by a, and I got that. So then I'm still trying to get this a by itself, so I'm going to need to multiply by 24 to the sine 32, and then divide by sine 108. So I'm going to do that here on my calculator. You guys can see this as I do this. First thing you do, check your mode. We're working with degrees, so I'm going to use degrees on this one. So make sure that that works out for you. So here we go. Second, quit, clear that out. So again, we got to have sine 32. So I'm going to do sine of 32. I'm going to close my parentheses to make sure that it's just sine of 32. I'm going to multiply that by 24, enter, and then I'm going to divide that by the sine of 108. Divide that by the sine of 108. And I get 13.37 or 13.4. We can go ahead and round it. So little a is equal to 13.4. And now let's go ahead and find little b. And if you want to, you can pause the video and try it on your own. If you want to just go right here, you can do this. So sine of 40 over little b equals sine of 108 over 24. And I'm going to try and use the 108 over 24 again, so I'm not using a rounded, the 13.4, because technically it was 13.37256-ish stuff. Same thing again here. I'm going to bring the b up, so I'm going to do sine 40. There we go, clear. Sine of 40, close parentheses, enter, times 24, enter, divided by sine of 108, enter, and I get 16.22, and I'll just round that to the 10th and call it 16.2, and I'll be okay with that. If I look at those, and both of those match up, I should have a bigger side across from a bigger angle, and 40 degrees is bigger than 32 degrees, so little b should be bigger than little a. And that's your first example of a problem dealing with law of sines. So if we want to try another one right now, let's go ahead and try this situation, an angle sine. So I'm just going to draw a picture out here right now. And let me just make it up right now. So let's do this. Let's do this as 43 degrees, and this one is 57 degrees, and this one is 8. And I want to know how big x is, and y is, and z is. So I'm going to try and find all three of those things. Well, in terms of the information that was given, I'm given an angle, and then a side that's following it. An angle, and the side, according to us, says we can use the law of sines. So they always have to match up for one of them, so I have to use 43 with the 8, so I'm going to do sine 43 over 8 equals, and I got to know this one first, so sine 57 over x, sine 57 over x. And again, bring the x up here, and multiply both sides by 8, so then I've got, here's my calculator, sine 57, enter, times 8, enter, divided by sine of 43, enter, and I get 9.837. So x is equal to 9.837. And then, again, you could find z by subtracting those two things from 180. So 43 and 57 is 100, so that means z must be 80 degrees. So then I can do sine of 80 over unknown side y equals, and I'll do sine of 43 over 8, just like that. Sorry, let me just go off the video just a little bit. So I'm going to do this one. So similar things again, sine 80 on my calculator, enter, times 8, enter, divided by sine of 43, and I get 11.55. So y equals 11.55. And I've now found all three of those bits of information from that one. So again, I kind of left you with the one that's the most difficult. So here we go. Let's deal with what happens with this SSA situation. This either a little side, big side angle, or a little side, big side angle that works for 2. This one worked for none, or big side, little side angle. And we're going to do these one at a time, and hopefully this will make sense to all of you. Here we go. So let's try this first picture. And let's go here, and let's go 20 degrees. We'll make this nice and small, and make this 12, and make this 2. So even though that's 20 degrees, that's really small angle. I don't think the 2 is going to touch. And there we go. Sorry about that. So I don't think the 2 is going to touch, but we're going to check it to see if it actually works out or doesn't work out. So what would be going on is pretend that touches up there, and this would be angle B, and we'll call this little b, and we'll call this a, and we'll call this little a, which means that if it works, that sine of 20 over 2 is equal to sine of b over 12. Okay, so I got that problem right there. So let's go ahead and try and solve this. So I'm trying to get the b by itself, right? So I'm going to have to do sine 20 divided by 2 and multiplied by 12, and then sine inverse. So here we go. Try and show you both on the same screen at the same time here. So sine of 20, enter, divided by 2, enter, like that. And then times by 12, enter. So you can see now that the sine of b is supposed to be 2.05. Well, let's check. Sine of b equals 2.05. You guys know, right? Sine pops up and down between 1 and -1. So that's out of its range. I can even show you on the calculator. So I'm going to do sine inverse of that answer. And you can see it's like, hey, that's not allowed. It's not in the right thing. And it even asks you to check. Maybe you're in the wrong mode, but we're not. We're in the right mode. So, okay. So this one was exactly what we thought. It was not possible. Okay, so let's try a second situation. Let's try this one. So let's make this like this, way up here, and make this 13, and make this one 10, and this one, I don't know, 35 degrees. So I believe that you can see by this representation, it is a side to side and an angle marking, but it is a big S followed by a little s, and then an A. And that was the third option. I wanted to leave the middle option for last because there's two possibilities on this one. This is the third option, big S, little s. Sorry, I should make that a big A. And we believe that this is one unique triangle. It should work. So let's try this. Let's go sine of unknown angle. We'll call this angle B up here. Sine of B over 10 equals sine of 35 over 13. And I'm going to go ahead and solve that one. So again, I'm trying to solve for an angle right now. So I've got to use my sine inverse in the end. So let's put the calculator right there again so you can see this. So I'm going to go on the right side first. So sine of 35, enter, divided by 13, enter. I'm going to times this by 10, enter. And now you can see that my ratio right here, 0.441, is between 0 and 1, so it should work. So now I get to sine inverse that answer, and you can see that it says that it's 26.18 degrees. So angle B equals 26.2 degrees. And you can see up there, I mean, I didn't draw this perfectly to scale, but it's probably pretty small. And that kind of makes sense, which, you know, I've been talking about this for a long time. So here we go. This is a situation where we're like, okay, what happens if I get two triangles? So little s, big S, A with two triangles. And this is the last one that we have to look at, and hopefully this is going to make sense for you at all. So I'm going to go here. I'm going to make this a pretty small angle again. I'm going to make this 20 degrees. Let's go ahead and make this 10. And then we're going to make this length be, I don't know, let's make it about like that. And if that's 10, then that's probably 5. Which means if I extended this out here like this, then I could probably have another 5 that goes out there like that. And you can see that I can get two different triangles with this. Okay? So I'm going to go ahead and do the first one and see how this works out for us. We're going to try and find that angle right there. So we're going to call this B, and this A, and this little a, and this little b. So I'm going to try and find the obtuse one first and see if that registers with you. So sine of b over 10 equals sine of 20 over 5. Handy dandy calculator, back out again, turn this on. So I'm going to do sine of 20, enter, make sure you close parentheses or hit enter, one of those two, divided by 5, enter, times by 10, enter, and then sine inverse of that answer. And you can see that I got an angle of 43.16. And you're like, if the measure of that angle is 43.16 degrees, and I was trying to find this one right here, that obviously doesn't make any sense. So what must have happened is I must have found this one right up in here instead, because that's the only one that makes sense for 43.16 degrees. Is that logical? Everybody make sure that that's good. And then if I can do that, and I know that that one's that, and now I've got a 20-degree angle. So I'm going to show you this one. So it must be that we're working on this triangle right here. So I got a 20-degree angle, a 43.16-degree angle, and then whatever's left here. And this was 5, and this was 10. So let's go ahead and find out what this missing angle is down here. So 180 minus 43.16 minus 20, and you can see that this is 116.4 degrees. And then if I wanted to find my missing third side right here, I can do the sine of 116.4 over unknown angle, we'll call it x in this case, equals sine of 20 over 5. And let's solve for that one. So I got to move my x over here again, so I get sine of that angle, enter, times 5, enter, divided by the sine of 20, and you can see that I get 13.09. And that makes sense. That's pretty long right there, 13.09. So now I've found all of those things, right? I found my missing angle there, my missing angle there, and my missing side, 13.09. But how did I lose this other triangle? Well, the issue is that when we're using law of sines, I'll give you this little example right over here. When we're using law of the sines, the sine of a 60-degree angle right here, and the sine of a 120-degree angle right here, because sine is positive in the first quadrant and the second quadrant, those are actually going to give me the same things on our triangles, or on our angles. So watch. So sine of 60, enter, sine of 120, enter, gives me the exact same numbers. So the calculator can't differentiate between whether you're finding the little angle or whether you're finding the big angle. So that's why we kind of have to draw the picture. So let's draw this picture again and see if this makes sense. So now I'm going to do the one that we missed out on, pretending again this is the one we just found before, right? This one right up here. Now we're going to use this one right here, and you're wondering, well, how the heck do I determine what that is? Well, it's not really that hard. If this is 43.16 degrees here, and those two things were the same length, then that must have been 43.16 degrees there, because it's an isosceles triangle, which means the obtuse angle right there has to be whatever's left over from 180. So I do 180 minus 43.16, and I get 136.84. So I know that this angle is 136.84. And you're like, whoa, that was kind of weird, right? So this is still 20 degrees. This is 5 over here, and this is 10 over here. And you're like, wait, are you sure I can just do that? So I'm going to try and clear this up for you right now. So watch. So sine of 43.16, I hit enter, and you see I get 0.684. And sine of 136.84, the new one that we said might also exist, and you can see I get the exact same thing on the calculator. So now I can go ahead and use this one. I'm going to go ahead and find out my third angle now, right? I make this third angle right here. We're going to call it y. I'm going to make that y, and then we're going to find little y. So that y is just 180 minus those two angles that we already know. So 180 minus 136.84 minus 20, enter, and I get 23.16 degrees. So that angle, measurement of that angle is 23.16 degrees. And doesn't that make a lot more sense? That's a little one in the corner, right? Again, these aren't drawn to scale, so, but you can tell it's definitely acute. Then my other angle was 136.84 degrees, right? We'll call that angle Z. Measure angle Z. And this one was Y, which just means the only thing I need to know is little y. And I can use whichever ones that I want. So I'm going to go ahead and do sine of 136.84 over 10 equals the sine of 23.16 over little y. Okay. Over there, hopefully you can see that okay. Trying to solve for little y. Again, I got to bring that up. So I get the sine of 23.16. I'm going to go ahead and put it right there. That'll be okay. Enter times 10. Enter. Divided by the sine of 136.84. Enter. And I find out it's 5.75. So little y is 5.75. Okay, so in summary about all this laws of sine stuff, law of sine is used for non or right triangles. Except right triangles, we can use SOHCAHTOA, so we don't need this necessarily. We can do it on an SSA, an AAS, or an ASA situation. If we given side angle side or side side side, that's law of cosines, different video. Okay? Little s big S A situation, little s big S A situation, different, not possible, can't touch. Two different triangles, got to find both. And big S little s A always going to work for one. So AAS, ASA, and big S little sa always work. And then I gave you examples of each one of these. Hopefully this was really helpful to you. Again, stay positive with your studies. Keep working on all of this stuff. I'm hoping this is beneficial. Peace out.